All right.
Yeah. All right, cool. Well, thanks everyone for coming. I will be doing the current obs, and then we're going to take a look at some kind of activity in the Pacific, how it might relate to what's been going on over the US, and some connections with the Madden-Julian oscillation, kind of feeding off of Stephanie Henderson's lecture on Wednesday. So currently, right now, looking at the radar across the US, pretty quiet in the western part of the United States, and there's this kind of linear rain band kind of extending from northern Texas all the way out to Pennsylvania or so, and then some kind of scattered, less linear looking precip happening to the north, and I think that's actually snow up there. And yesterday, it's kind of gross over us right now, and yesterday we had some really pleasant freezing rain. It was raining, it was just raining when I walked home last night around 5:30, which I was not expecting. It's gonna ruin my down jacket. But anyway, hasn't been that pleasant over us. So this linear band of precip, and then a little bit of activity going on over Louisiana is kind of the main story in terms of precipitation for right now. So Pete, can we go to the visible satellite imagery, please?
It's rained almost incessantly, like it was predicted to in Arkansas. And actually along the whole Ohio River Valley. Last week we were talking about that. It really came to fruition, didn't it?
Yeah, so and they're under a pretty big flood watch right now, I think, or all across. Yeah, I have the hazards map up. We can take a look at that. So looking at large scale picture from satellite, visible from GOES 16. You can see the really thick, heavy cloud band associated with all that rain going on in the central US. And you can tell that that's kind of on the western edge of this very strong anticyclone that's been sitting over the southeast US and actually just the eastern US, leading to a lot of record-breaking warmth over that area for quite a while. Which we sadly, I mean, I think we have to be above normal right now in terms of warmth.
Probably,
but yeah, but nothing like last year where, and this is something I'm interested in, is that right now we have a West Pacific jet that's very retracted. We are warmer than average over us right now, and the solstice parties tonight. And last year we had the exact same situation where Maria and I were sitting outside because it was 70 degrees. And the jet was retracted in the West Pacific, and the solstice party was that night. So something fun's going on there where, nice. But we're not nearly as warm as last year, which is too bad. But we still are warmer than usual. Okay, so what else is going on? So it looks like there was I think there's still some low-level fog in Kansas and Oklahoma. At first I thought that to the north that was all snow. And I know it's not all our snow is melted, and it's kind of hard to see. I was looking, can we look at just over the US? Yeah.
Before can we go back one thing? I just wanted to see point out the storm to the east of Greenland, which is a monster cyclone.
Oh, yeah.
It's too bad we don't have a better angle. And you can see the cold air funneling off the continent over a broad area of the North Atlantic. That's one of the more dramatic things that I've seen all winter long. We haven't really had one of those extraordinary cold air outbreaks over the continental North America. But it's only of the United States, but this is a really dramatic one. Great way to get rid of the cold air in the lower troposphere is to put it over warmer water at this time of year. That's really doing something.
Really good, get rid of it. Yeah, and so, and Michael was talking earlier in the week about a pretty big block in the North Atlantic.
That was forecast.
It's
still 3 days out now, I guess, relative to when we're talking about it.
So it's still coming?
I haven't looked at the recent forecast, seem to have backed off a little bit.
Okay.
We could check it out in the longer term.
Okay, that's interesting. I did see in the observations, there was a pretty high amplitude ridge out there that already kind of, overturned anticyclonically a few days ago. So I thought that's what you were talking about. This is actually something different.
I think it was there, and it was continuing to evolve through this time period up until early next week. So that may be the initial stages of it.
Okay, gotcha. Very interesting. Yeah, Luke was talking about how cold it might get over England. They've kind of been bracing for that. So maybe some blocking in the Atlantic, but right now it looks like it's characterized by a really nice deep cyclone, actually. Yeah, so let's just look at the 6-hour loop. And I'm going to try and see if I can point out what I was seeing. It looked like GOES 16 could actually pick out where there was snow versus clouds, yeah, over that. And it looked even
Oh, yeah.
brighter earlier, I think. Maybe I was just making up what I saw. But you definitely can see the movement of the clouds over the snow, which is pretty incredible. And there is still snow covering most of the Dakotas there and a lot of the west. So that's kind of all I wanted to see.
It's also kind of neat that over the southeast United States where it's relatively clear earlier today, you see all this cumulonimbus clouds
Yeah.
just developing.
Yeah.
I don't know if it's always a function of the ground getting heated up enough, but I wonder if it's also a function of plants beginning to open up. I don't know if it's the cycle of plants, leaves beginning to reopen in the far southeast might have already started.
Yeah,
So
maybe.
that's contributing to evapotranspiration.
Could be, yeah. It's very dramatic.
They're starting down there, but I don't think there's enough of them yet to make a big difference.
But
Make some difference.
but it does have the advantage of having a tropical moisture feed for a week from the Caribbean. So as soon as it gets over the land of local hotspots, that might be enough in this particular instance.
Yeah.
Yeah, and if I remember looking, we'll look at the surface clouds in a second, you can check, but I believe that down kind of in Kentucky and parts of Georgia and Tennessee, they are in the 70s right now.
Yeah,
something
yeah,
already.
very warm. Yeah,
Yeah,
really warm
already.
out there.
So
Well, I was in DC the last couple of days. You know how warm it was there?
81
It was
on
like
Wednesday,
80,
right?
Yeah.
Yeah, it was 80.
First time
Yeah.
ever in February.
that's
Earliest
pretty incredible. And I wish I could say what was going to happen next. A lot of the maps that I've been looking at have been kind of the last 10 days, but there's been this problem with the data, so that all the Albany pages
Oh,
kind
yeah.
of stop at the 21st, which is unfortunate. But maybe we'll see if that's going to persist into the future.
This is a band that we don't typically look at. This is one of the new bands on Go 16. It's a snow and ice channel. I forget the frequency that it's at, but typically grayer tends to be ice and whiter tends to be liquid. So it helps you kind of
See where the
yeah,
really,
I think
really-
that's what the interpretation is.
is that.
I was just looking to see if we could tell the difference between the snow and the clouds, or the fog and the snow.
Right, yeah, so like
You can,
all
you can.
of this is actually snow.
Yeah.
So it works for the cloud
That's
tops
what
and
we
for the ground. That's interesting. Yeah, a lot of low
And
level
this is the
fog.
upper level. There's another band that's kind of cool to look at sometimes, this Cirrus band. We'll loop it, but it shows you, it tends to be more upper level cloud Cirrus kind of stuff.
Yeah, and then this kind of, is this some sort of, must be a cyclonic disturbance. I'm not sure, I know right now, actually, if you just flip to the last tab up there, Pete, just the national hazards page. So just looking at, you see all the flooding that is kind of ongoing right now, that's leading to a warning. And then there seems to be some sort of winter storm watch. So I don't know if, well, over here, it must be tied to that really weak cyclonic disturbance. I don't know where that's going to go in the future because there's nothing really happening right now in terms of precipitation in Nebraska or Minnesota.
Right, I think that cloud distribution, see over the Rocky Mountains is going to be part of the next weather system that gives us rain. So.
Oh, okay, gotcha. So that is all cool. And just while we're here, I mean, there's a lot going on, but there's a lot of Hawaiian flooding, flash flooding warnings out over in Hawaii. And that has, again, to do with the retracted jet. You get this dipole type lock, a lot of Kona lows, in that case, a lot of subtropical cyclogenesis. And that has been the state for the last 10 days or so, and it looks like it's going to continue to be very shooting that. Okay, let's go back to the satellite, please. And why don't we actually go to surface obs? What's going on locally? Yep, so it's 37, very overcast over much of the Midwest. Still a little bit of haze and fog lingering. Then if we go out to the east, let's see how warm it is. It looks like kind of gradually transitioning from 30s to us to 60s and 70s in where are we? Kentucky and West Virginia. So not as warm as it has been. And let's see what DC or that area is like right now. They're back in the 40s.
Look at 25 degrees between Little Rock and Meridian, Mississippi. 78 with a 66 dew point in the southeasterly or southwesterly wind, and then 53 at Little Rock.
Yeah, wow, yeah, there, and even 57, 75. So that's a pretty start. And you see a really big wind shift there too. So
80s in central Alabama.
yeah.
Unbelievable.
That would be nice.
Yeah.
Meanwhile, I'm just happy I don't have to wear my down jacket today, but.
Or cleats, no ice. That's
It's
nice.
been cold for spring training, look at that. 40s.
Oh, yeah, that's right.
Monday is supposed to be the warmest day they've had, and that's only 70.
That's not what they expect.
Yeah.
Grapefruit League beats Cactus League in week 1.
Yeah, I guess so, this year.
You guys been talking
Oh.
about.
Frozen fruit.
Well, they have 2 spring training sites traditionally, Florida or Arizona. And
And they picked their.
the teams split up, so they always go back to the same one. Brewers always go to Arizona, but the Red Sox go to Florida. And they have a pretty good week to start this week. Brewers didn't, kind of chill.
Yeah, gotcha,
And that's what
gotcha.
they call the teams that go to Arizona, it's a Cactus League, and the teams that go to Florida, it's a Grapefruit League. And they'll play each other for spring training.
Okay, I see. Good to learn about that.
You never know what you're gonna learn.
Yeah, that's right.
Yeah. And then meanwhile, I guess while we're out here looking at temperatures in California, it's all in the 40s and 50s in Southern California. So I'm guessing that's pretty cold for them. There's been a trough over that for them for a while. I actually can't say for sure because I know California's for sure. You know, when they're warmest or coldest, it's strange. So.
And I'd guess that, I know Los Angeles' coldest month at 850 is March. So I would guess when
Okay.
you're in late February, you're already kind of into that. So
Yeah,
it is the
maybe
coldest
it-
time of year for them at just a mile above sea level.
All right, so maybe it's not actually colder than average.
Probably not, yeah.
Okay.
It's not a really great place to go for spring break. It's early March for that
Gotcha.
reason.
At least right now. I know that there have been periods lately that they have been characterized by a trough there, but they might
Yeah.
not be right now. A lot of the pages I've been looking at stuff
Oh,
over the last couple of days. I haven't really looked at more. Okay, so I think that's it for surface obs. Generally, a little bit of snow in Utah. Not really much going on, just boring temperatures. So why don't we go to the super peaks and take a look. Let's just take a look at 700. I know 850 is kind of a disaster. Yeah, so there is this broad trough kind of over the western part of the United States, but it's still not, California is not really in the center of it, so it still might not be colder than normal. It's cold. Patterns may be shifting to the east a little bit. And you see again that really nice low-level anticyclone that's been quite persistent. And we are just in a region of kind of very straight, broad, southwesterly flow. But not really warming up anymore. There's not much temperature contrast. But there is a very nice mean temperature gradient kind of draping across the United States. So why don't we just go up right to the jet level at 300 and see how it's going. Yeah, so fairly strong jet. It even looks strong, a little bit stronger this morning. That's right where you would expect it to be. And that's probably why that really weak, low pressure system that occurred over us last night. I think the low as of this morning was like 1013 or something, but that thing's not going to be just able to develop in, a jet streak in that location. It's just going to get sheared out, I would say. So I always get lost on these maps, what's actually curving and what's the projection, but you do get a sense of a really broad ridge out in the eastern Pacific and possibly some wave breaking occurring where it's digging out this steep trough over the western United States. It's a little hard to tell on this projection, but we'll take a look at more Pacific maps in a little bit. Great.
Now, I always want to talk about where these jets actually are. That jet, right there, the main one you see.
Yeah.
Is a subtropical jet, and it connects all the way back to Asia, believe it or not. You're saying it's retracted. I see it going straight across Hawaii. And
So more southward shifted.
yeah, there's a jet stream going all the way to Hawaii. You'd have to look at the 12Z or the 12Z or 18Z rather, because today's is not. But look at that.
Yeah, I mean, okay, I guess I see what you mean.
You can see from the first frame that it's connected, and it's still got some subtropical, but that part to the north again is the polar night jet.
Yeah, that's right. That's
That's what we looked at
teal
last week. It
color.
goes all the way up. What's
yeah.
interesting is it completely fizzles over the next couple of days.
Really?
And it reforms back at the pole. So you look at that boom up there.
Yeah. Oh,
You see it going all the way across?
right. And so this is all actually connected to that high north, right?
Right.
So,
Yeah, I don't understand, but I thought when you get a sudden stratospheric warming, that was the end, but it looks like it's reforming again.
yeah,
It's
that's
up at the pole.
interesting.
And at the same time, you have this unbelievably continuous jet streak all the way from Asia it's across the entire globe just about,
Yeah, yeah.
which is fairly unusual. And you see it over Hawaii right there.
Right. So in defense of what I mean by retraction, usually you have your jet streak to the north, not split like that. So saying retracted might be misleading, but really the flow is definitely split. And I do see your point that some of that is connected. It's just very far southward shifted.
Yeah,
Better way.
that's been typical this year. Remember we saw one of the jet streaks on the equator before, which.
Yeah.
In fact, there's another little one down there near the equator.
Right.
Those are
Right.
40 meter per second jet surfaces there, so that's pretty strong.
That's
At the same
interesting.
time, I know there's the QBO up there. If you go up a little above all this, it's straight easterly, right across the equator.
Very easterly. Okay. I don't know anything about the QBO. So what is that?
Well, the QBO is centered up more around 30 kilometers above the ground. And it flips every other year. It's easterly one year and westerly the next.
Okay.
It's been
just wind
acting
speeds.
bizarre the last couple of years, like being easterly 2 years in a row.
What's it stand for?
QBO,
Quasi-biennial oscillation.
biennial oscillation.
Yeah, that's interesting. I just saw a paper that got published in Nature about links between the MJO and the QBO and then enhanced seasonal predictability. And right now we have a really strong MJO happening, or it just occurred, and maybe a strange QBO.
Well,
So
that's right. I actually have been looking at a little bit of that, and not the MJ, but the Walker circulation, when it gets really strong over Asia, there's a continuous easterly flow all the way up into the QBO. At least there was last summer. I haven't looked at it the last few days. But it's as if the tropical easterly jet that would be over southern Asia can extend all the way down to low levels, all the way up to the QBO levels, all the way up into the middle stratosphere.
interesting. And that's specifically kind of when you have convection concentrated here.
During the monsoon period is when I was looking at it. I don't know if it's doing that now, but it was last summer. And what was interesting about that is that seemed to have something to do with the series of tropical cyclones we had last summer.
Yeah, interesting. Yeah, well, I do know, and I have OLR up here somewhere for the last very long time period in from -10 to 10. So let's see, maybe that climate page. Yeah, one more. Okay, that's the MJO, and so next one, the Ezreal one. Yeah, so this is at Hofmahler of outgoing long wave radiation, averaged over the tropics, so -10 south to 10 north, and 10 south to 10 north. And it's this has a very long record all the way back to last year. But so right now, the last few months are all kind of concentrated in this area. But I just wanted to point out, since we're talking about it, that we have had more convection than normal. All these blue shading, that indicates negative OLR, so more convection. And that's all been kind of concentrated in this kind of La Nina-like condition over the maritime continent. So maybe that is something to do. We've been a little bit more La Nina-like than El Nino this year.
Yeah.
So
So it's finally bleeding towards the date line for the first
Yes.
time all cold season.
Yep.
And I think that might be why you get this little blip of a jet feature around Hawaii, right near Hawaii, because I think it might just be outflow from this persistent convection. And it's about a week or so long now, even on this diagram. And that's the first time all year it's been in that location.
yeah, and so I think, and so that's a good point. While we're here, you can kind of look at all of these negative OLR streaks and then this region of positive OLR, so suppressed convection over the West Pacific. They're all, they're not really propagating in time. They're not slanted. That's the MJO.
Yeah, that's finally a disturbance
Yeah.
that moves.
Right. And then it's stalled kind of recently. It's been a little bit stalled in the West Pacific for a while. But it's weakening right now and it's kind of moved on. So I think the jet feature we're seeing is actually more a function of the subtropical cyclogenesis
Oh, okay.
and the mid-latitudes. But I think they work in conjunction.
Yeah.
I think they're all related, and that's kind of what I'm trying to piece together.
In interpreting this Hofmahler diagram, you're saying that there really hasn't been a significant MJO event in the last year, or at least one that made it to the date line? Let's go back to May of last year, or the.
Yeah, I haven't looked too much at the past record, and I do know that before the last retraction, which is, exactly a year ago, so it's not really shown here, but there was another strong MJO in cases 7 and 8, like there is in this fashion. But other than that, yeah, it looks like there hasn't been that much.
So that's been parked about 120 until now. It's moving.
Yeah, so actually a good way to look at this, if you can go to the climate page right to the left, so we can maybe figure it out with the MJO diagram. So the way you read this is the MJO kind of moves around from the Indian Ocean, Maritime Continent, Pacific, and this line is showing the 14th of January where the MJO was, and then how it's moved since then. And then this red line is where it's been in February. So it looks like that, and we don't know when it started because we don't have that history, but since mid-January, there was kind of a slow progression through the Maritime Continent, very steady, not too rapid, and then something happens where it just races across the Western Pacific Maritime Continent at extremely high amplitude. So that's kind of how I would view when it's moving or not, because that Hofmahler is a little confusing when you're looking at 50 weeks to me. So to me, it looks like it was moving more slowly over the Maritime Continent. So I think that's actually what you saw in the OLR, where it was stuck there for a longer period of time.
Well, it looked like it was stuck around 120, which is actually a little east of the Maritime Continent.
Yeah, right.
And that's what I was saying. I think last week I was pointing out that the Walker, or that the Chi field, the velocity potential was showing a maximum actually to the east of Asia. And I think that
Right.
matches what you're showing.
Yeah, that totally does. That was probably the MJO moving finally off of where it was before.
It's difficult to, I mean, is the MJO the same as the Walker circulation? I don't know. It certainly is related.
Right.
I can't say it's not.
Yeah, and their interactions are fascinating. When you have MJO plus El Nino versus MJO plus La Nina, when are they reinforcing each other? When are they fighting each other? Is something I think is really interesting. I bet if Steph was here, she would know exactly what to say about it. But
Not to mention the mid-latitudes.
right.
Features from the mid-latitudes can come down, and I don't think they get controlled by this any more than it controls the mid-latitudes.
Yeah,
think
so
they-
the 2-8, right.
Yeah.
But moving toward the date line is more El Nino, right? When it gets that far east.
Yeah, it's approaching it. And so maybe we can look back at the Hofmahlers, but just thinking about February, I mean, it was moving very rapidly late January, early February, and then it just started weakening and didn't really move laterally at all. But it's still, and then it finally kind of got its act together and started propagating the last few days. So I completely forgot what I was going to say along those lines. But at any rate, I don't know how persistent, how long-lived, or how strong the MJO is right now in terms of activity. And then, and one other interesting thing, this has been talked about on the map list a lot, is the forecast busts that are accompanied by the MJO. And actually, Andrew mentioned that during this period where the MJO stalled and then kind of weakened, that's right when the jet was kind of weakening or splitting, was one of the biggest forecast error they've seen all winter.
You know, that stall period, isn't that coincident with the sun stratosphere point? When
Yes.
the polar vortex died, then the MJO stalls?
Right, and so
Who's causing what?
Yeah, very good point. So Paul Rondi, I think, said something, I'll try to quote him on the map list. He said that MJO-induced Rossby wave breaking helped split the stratosphere, or the vortex, and then they interacted. And I think no one can say anything more specific than that at this time, because it's very hard to parse those out.
Well, it's during that period that the polar vortex moved over Canada, that we saw last week.
Right.
And it
right.
disappeared over the Pacific.
Yeah, and so we can take a look at this very high amplitude wave breaking that occurred in the Eastern Pacific right at that time.
Yeah.
So actually, I think we can, So we'll just take a look at this map for a second, because we don't have as many height anomaly days. But just to point out, so this was for February 13th, right when you had an MJO probably like here or so. And you see that already, and this is a little bit late in the period, but there's this wave breaking occurring over the Eastern Pacific. And looking at the jet, we've been in this retracted state for a long time. But again, that can be muddled with some sort of contiguous jet that's just shifted way far south of where it usually is, which it looks like from Greg's point of view, from his maps, that might be the case. So can we go to the next Albany page, please? And so this, again, sorry we're switching around so much with the maps, but we might use these for quite a while. So this is showing the standardized height anomalies at 250 millibars, and we are looking at February 9th. So in this case, you can see that there's very, very high amplitude ridge that's extending out into the poles. So was this ridge formed by the MJO and then somehow was able to reach into the, into the Arctic region and start messing around with the polar vortex? Looks like it's high enough in amplitude too. And it's hard to tell on Mercator, but it does look like that this thing was somehow being stretched and manipulated by a flow up there, maybe weakening it.
What's the, in a concise way, how would you describe what identifies the MJO? I mean, when you say it's something that has influenced the ridge, would it be is it the outflow from the convection that's associated with it? What are the markers for it?
Yeah.
On this phase diagram?
So that's something that I struggle with. So the phase diagram we've been looking at is this like multivariate index based on outgoing long wave radiation, surface winds, and upper level winds. So 850, 250, and OLR are all working together. I think that, if you have anomalous convection, you're going to have an instantaneous relationship with the jet. If you put a big anticyclone from mass outflow here in the west or central Pacific, its immediate effect is to strengthen the jet, right?
Right, exactly.
Exactly what a lot of work we've been looking at is showing. And then it seems like there's also discussion then about the wave trains initiated by that cyclone or by that anticyclonic kind of disturbance that might start perturbing movement along the jet. I think that those teleconnections are extremely case dependent based on what your jet was already like, what are the mid-latitudes doing already, and all of that. So I think that's a lot harder to parse out than you have convection here, you're going to be eroding PV, building up this hill, and strengthening, possibly extending the jet. That to me seems more robust of the immediate response than the teleconnection. So back to why would an MJO then form a ridge if it's over here? I think that has to do with if your jet extends and strengthens, you get a big cyclone that then just, that just builds a ridge almost by chance or something. I'm not really sure. But
I don't think any of us are really sure, to be honest
No.
with you. I think you encapsulated it a little bit in your description just there. It seems to me that it depends critically on what the jet structure is, whether or not disturbances out of the tropics and subtropics are going to have an impact on the extratropics. And so one can't really make broad statements because the jet is so variable. And it's part of that variability is a result of the convection, like you're saying, in the tropics. And other parts of the variability is because of what's going on polar of the jet axis.
Right.
So it's just a whole bunch of factors that figure into this. So when people quickly, in a matter of days, can say this seemed to have been caused by the MJO, I don't know what they mean by that. I get confused.
Yeah, that's sort of my take as well. I'm wondering, do we have, it may be heresy to say this, but do we have to appeal to the MJO at all for any of these things? It's a useful, maybe it's a structure or it's a conceptual model that we can put our minds in, understand this propagation of convection westward from the Indian Ocean, but fundamentally, I think you said it's due to the convection, due to the diabatic erosion of PV, et cetera. You could instantaneously, synoptically see these signals and say, okay, I can infer what the impact is going to be.
Right, yeah. And I agree, it's half the story. And one of the fun parts is that with a linear inverse model, if you have some information about the tropics and the mid-latitudes, you can start shutting off those interactions. And for blocking, our blocking criteria is it's generally in the region that we're in blocking right now. If you eliminate the tropics doing anything, you still get the development of a feature there.
Hmm.
It's weaker in magnitude, but it's in the same exact place. And so to me, that's saying mid latitudes are driving that specific type.
Yeah, and then it's also saying perhaps implicitly that there's a resonance under certain structures for what goes on in the tropics. They can resonate with structures that the mid-latitudes might be able to assemble on their own in weaker form.
Right.
And that's a really interesting problem right there, because that might be the thing that differentiates cases where when you're in phase 6 of the MJO, you don't get a block versus phases 6 and 7
Right.
where you do get a block.
Right.
What is it about the difference? You know?
Yeah. And Steph, I think she's said exactly that not
Yeah.
all MJOs produce blocking in certain areas or things like that.
Yeah.
So I think that the focus is there because we can see it in an MJO
Yeah.
more quickly than other things.
Right. I think it's a great problem. I mean, but I think it's less well answered than sometimes discussions suggest. Not yours, but
Right.
sometimes discussions quickly can suggest we understand this better than I think we really do.
Right.
Is
Yeah.
the MJO modulating the predictability somehow of any of this stuff? I mean, you can make an argument that it would be in certain situations. So like going back to the tropical cyclones interacting with jets and that connection to
Yeah.
predictability, is there work out there that is showing that in certain phases that maybe those interactions are more likely to happen and more uncertain just because it's convection inherently uncertain that then causes uncertainty in the downstream wave pattern?
I think Michael Reimer has I can't remember who his co-authors are or if I'm even right about this, but it seems to me in the summertime I was putting a proposal together. I remember reading a paper that talked about aspects of this very thing, Ryan, and it was quite interesting, and I think it did talk about predictability or at least wave structures downstream. Reimer 2010, Reimer et al. 2010 is the one that's coming to mind.
Yeah, I'm not familiar, but the entire.
There's some common knowledge about some of this.
Right. No, I mean, the entire like subseasonal to seasonal predictability task force that we're a part of is, I mean, half of those people are looking at MJO.
Yeah, when I say predictability, I mean like 3 to 7 days or something like that, not necessarily
Oh, okay. Yeah.
next month.
Right. Yeah.
Some
Yeah.
seasonal time scale.
I'm not sure. And I mean, I think it gets further confused with that. You see something strong in phase 3, you still don't know how quickly it's going to move into phase 4. If it does, at what strength, at what time.
Yeah.
It's completely, it's just, so then I don't know how much predictability you get out of it if you can't even predict when it's going to move.
Right.
on.
Or even a decrease in predictability. I think you're getting at sort of like the MJO is to tropical cyclones. I mean, it's a low frequency version of the impact convection would have, like a tropical cyclone convection would have on a jet in the Pacific. Is that kind of
Presumably the tropical cyclone, at least you know where it's going and your structure, and maybe it's just an uncertainty of the interaction.
Right.
There, you sort of have this broad area of what's going on. It's chaotic.
Not you.
right?
I don't know.
The anomalous thing that's going on right now, and I think that they said this last week too, that still now, is there's no tropical plumes of any consequence right now in the northern hemisphere. It was like that last week, and it was during the week, it was kind of over the southeast, but it didn't get that far north. There's nothing going on in the Arctic right now. It's completely tropical plumes. But the southern hemisphere is going like crazy. And it's kind of early because it's usually in the winter hemisphere
Right.
where you get tropical plumes. The southern hemisphere is erupting with lots of tropical plumes. So why is that?
Yeah.
I don't know. Look at the Chi field. Look at the velocity potential there. Just get an idea. On the 18 was go down.
Further down,
It's
further
down further. Just the velocity.
Oh,
18 is even. Now there's a velocity potential. That's where you see the maximum rising motion when it's blue.
Yeah, right.
And see how it's kind of shifted over east where it would normally be.
So is it usually like here?
Yeah, it would usually be sitting over more of an intersecting into India right now. But yeah, it's a little east. It's not quite over the maritime continent. It's centered there. It's centered a little bit east.
Yeah.
But you can't really see it. Go to the inertial frequency plot so you can see the tropical plumes usually. Oh, those are the top 348. Yeah, down there. 322. Okay, you look in the southern hemisphere, you see the tropical plume. Okay, I do see one in the northern hemisphere, the Pacific. This is an 8-day forecast, so we have the one over us. And then there's a minor, there's an eruption in the Pacific next week. But look at all the ones coming out
Oh,
of the
yeah,
southern
I think I
hemisphere.
see what, so like
That right
that,
there,
yeah.
The other thing you see is you see that band of cyclones forming at about 25 degrees south. And then these are in the upper
Oh,
airflow.
like-
You see them best around 10 kilometers. This is,
Here, those?
yeah, that situation is one I'm trying to figure out what it means, but that happened last year, a couple days before the 3 cyclones formed in the Atlantic.
Yeah.
The 3 tropical, Harvey, Irma, and Marie. This happened before that. What the effect of this, when you get those little cyclones, and they only exist between about 8 and 11 or 12 kilometers above the ground. They're just in this narrow region, and Michael and I were contemplating maybe this is some kind of a barotropic instability, because what happens is you get these tropical plumes going south, and then they leave this band of relatively high inertial frequency. And in that band, you can sort of see that they're all across the globe. These things are forming like a wave number 10 or 15.
It's really
Across the
small,
globe.
yeah.
And the effect of those is because they're in a negative vorticity gradient, negative potential vorticity, but the net effect is to drive negative potential vorticity from the equator poleward. And so these negative potential vorticity plumes reestablish the low inertial frequency or the tropics and reestablish it at a higher latitude, which is, I think, what's happening in the southern hemisphere right now.
Interesting.
So it's sort of shifting this tropical trouble clause into the southern hemisphere south more. Nobody ever looks at this because this is an elevation where nobody ever plots a map. These little cyclones, nobody would even know they're there, but they're there.
Right.
And they have this effect of pluming low potential vorticity mid-level south. And I think the effect was to cause a low enough inertial frequency in the tropics to cause that whole period of, that whole episode of 3 amazing hurricanes last summer.
Yeah,
in the northern
really.
So let's see if we have an amazing episode of hurricanes start to form in the next week or 2 in the southern hemisphere.
Southern hemisphere. Wow.
In the Pacific.
Really
But
interesting.
that's what happens, but I think you can't just look at that isolated because, like I said, there's anomalous stuff going on in the northern hemisphere right now that's linked to why this stuff is going on in the southern hemisphere.
Right.
And it all has to do with how the tropics are going to get rid of their heat.
Mhm.
And are they going to plume it to the poles in the north, or are they going to plume it to the pole in the south? They're not pluming it all the way to the pole in the south right now, but they have a lot of plumes. They're not going to the poles. That's why you don't see much going on down at the Antarctica. They're just not getting down there.
Right, yeah.
But there is an occasional plume getting in the northern hemisphere. You see those ones, they're weak, they're pathetic. The ones in the northern hemisphere, the Atlantic.
So like where? Like
Yeah, that one there.
Yeah.
They're kind of pathetic compared to what we've seen. Maybe now that this vortex, the polar vortex has moved back,
Yeah. if it
maybe we'll start
reestablishes
seeing it.
itself.
Well, this is next 8 days. This isn't now.
Right, right, yeah.
So
that's
maybe we are
important.
starting to see a tendency to see that one blow up in the Atlantic or Pacific. So
Yeah.
we may start seeing more of that.
Yeah, interesting. Do you think any of that southward shift of this, to the, like the tropopause and all that, I mean, is that like related to the weird QBO at all? That's in the tropics, right?
I don't know. I mean, there's a ton of things you can do once you
Yeah.
recognize that those waves are actually there.
Right,
You
right.
never even knew about them
Yeah, that's interesting.
until I just happened to look at that level for no reason, and all of a sudden, well, what is going on there? All those waves, all in a
Right.
row.
That's interesting. And just one thing that I'm still interested in that I keep staring at, maybe I have Hawaii goggles, but this region of higher inertial frequency, I mean, that's kind of showing where trough is, right?
The red.
Yeah,
The
right.
red is high
So this
curvature, which is
blob-
normally, yeah.
Yeah, so this, I mean, so for Hawaii to be under a flooding warning, you would want a subtropical trough right there, and it looks like.
No, you wouldn't.
the-
You wouldn't. What you want is a trough and a plume. Because the trough and the plume together, the plume unleashes the upper atmosphere, the trough creates vertical motion in the lower atmosphere, and together they form deep convection.
Yeah, but if you're already in the subtropics, you don't need the plume. If you're at
They're
Hawaii, you
under a
don't
flood
need it.
warning right
Oh,
now.
well, I mean,
They're under
right
a flood
there.
warning right now.
Yeah.
You have some inertial frequency in the subtropics, but what you're seeing, you see that kind of noise stuff starts to develop, like the spokification, right?
Yeah.
over Hawaii.
Yeah, the really,
Yeah.
like that, yeah.
That is the wrinkling of the potential, that is the wrinkling of the isotropic surface that's causing that. And I think it's wrinkling by the jet stream. The jet stream is coming into that region and breaking up, and it's forming these pockets of vertical motion as it breaks up. And I think it's breaking up because of that little low inertial frequency region that's intercepted. Whenever we see severe weather, we tend to see these plumes of blue moving in. But the best severe weather is when you have a red
Next to it,
next to it.
yeah.
And the red really drives the low levels to want to have vertical motion. The plume lets it establish that circulation to the upper levels.
Gotcha, yeah, I
Brings it
mean,
up.
moisture and lifting, right, that's like a classic
But
combo.
if you lift it up, but then where are you going to put it?
Yeah, right,
Because convection adds
so
energy
that's
to
where
the
the
lift.
inertial
And so the
frequency.
convection would have to do all that work to push the stuff out of the way. But if you have the blue stuff, there's no work.
Right, it's just for free moving,
It's
moving
free.
in that direction.
Give it a free ride. So, yeah, I think
Yeah.
that's probably why Hawaii's getting so crazy right now.
So Greg, what does that say about the planes near the end of this forecast in the US? Because I see sort of what you're talking about going on.
Yeah, right there. Well, there was a period in the middle there.
That's, yeah, that's,
Right there, yeah. When that happens at this time of the year, that's when you get some of these severe weather situations. If you have the right cape and everything at low levels. Assuming it's conditioning unstable at low levels, and you got that happening there, then that would allow more of a widespread outbreak. I think what we see is, we've seen that 100% of severe weather outbreaks, where you have dozens or hundreds of supercells, those seem to occur 100% of the time when this is happening, when you have this subtropical plume coming out from the tropics, because it allows many supercells to develop at the same time, and they don't compete with their outputs, because they have plenty of low inertial frequency, low inertial resistance, so that they all can happen. So if this is happening and you got the conditional instability, then you got some of the ingredients, at least for an outbreak.
Very interesting. Well, I think we've exhausted some of our MJO jet tropical plume QBO talk for the day. So I think Michael had some forecast
Just a little bit.
maps. Yeah, just a little bit of what's going to happen in the future. Besides whatever's going to
Thanks.
happen. Yeah.
Thanks. We already have scroll down to the bottom, to my the meteorogram, John's favorite word.
Mhm.
And the key thing is, I mean, temperatures this weekend not really warming up a lot or cooling off significantly. You can see that our high today and the high on Sunday are probably roughly about the same. But the key thing here is we're looking for some more rain. You know, with the significant rainfall we've seen over the last week or so, with flood warnings and watches out to our south in northern Illinois and southern Wisconsin. Now, this is just going to exacerbate the situation. Part of it's the frozen ground, the rain's falling on and cooling up. I have water in my front yard that's just sitting on top of frozen ground that froze up last couple days and melted this morning. So it's just a pool of water there. And so we're anticipating even more rain, maybe a little, a third of an inch or so, perhaps over the weekend. That'll be starting on tomorrow evening and continuing through mid-morning on Sunday if this forecast is correct. Let's look at the time height section and get a sense of what's going on in the upper troposphere. And we can see, again, the red is the relative humidity, yellows are potential temperature. You can see the relative humidity in the mid-troposphere really increased significantly, and this is either due to maybe some cooling. You can see the isotopes building up a little bit, but also maybe an advection of higher water vapor content air into the mid-troposphere. But any doesn't really matter. Relative humidities go up, vertical motions also increase significantly, and that's around the timing of the beginning of our precipitation. We can also see that our dynamic tropopause, the 1.5 PVU surface that's shown here, gets lowered. You can see we have a very small bit of a trough-like feature that passes through here, maybe even tropopause through Wisconsin. So we'll take a look at what's going on in the upper troposphere as that goes by, but that's perhaps where the most interesting and dynamic part of the weekend forecast be influenced by. This is sometimes Sunday morning that's expected to approach. It's very well developed trough we'll see in the diagnostics. Let's go back quick, please. And first, let's look at 500 millibar analysis. Let's start at 12 hours of the forecast. So this evening, see in the mid-troposphere, there's an area of low at negative relative vorticity. That shows this is absolute vorticity that's shown here. That's across parts of the state. We have the broad southwesterly flow over us, and this very significant upper trough located out over the southwestern part of the United States. Those of you forecasting in Flagstaff, Nevada, this week it's been miserable with temperatures and precip. They are getting precip today. I think they've already done at least 500ths of an inch, and they should end up with 1300ths if everything is accurate. At least that's what I forecasted. See if the atmosphere actually cooperates with me. But this broad upper trough is one of the key features responsible for that precipitation. Let's go ahead to 12 hours further out. Tomorrow morning, 12 hours. See that trough continue to advance to the east. We still are in this broad southwesterly flow. It's a pretty significant curvature around this trough, so we might imagine that there may be some significant divergence emerging into the southern plains later on tomorrow evening. Another potent upper trough of the northwesterly flow just off the west coast of the United States. Go ahead another 36 hours, please. So 0Z. This is Saturday evening, excuse me. As the trough with the curvature has kind of been lost a little bit. Well, it's actually still fairly well curved, nice vorticity maxima at the base of this trough. And again, this flow is just broadly out of the southwest with this changing curvature from this really tightly curved flow to more of an anticyclone. Again, this would favor significant divergence in the troposphere downstream of that trough. As I imagine that's going to be also further to the north. And the southeastern ridge just sort of one type. A lot of rain in the south central part of the United States, but also some precipitation associated with this. This is roughly around the time that I guess precipitation was just about to start in our area. Let's go ahead. Another 12 hours ahead. This Saturday, our Sunday morning, really nice trough that's going by, and look at the changing curvature from positively, or positive curvature to anticyclonically curved flow. We're going to be right in that nice position to get some significant rain. That's when, this is during the period where the rain is just about over for us, just as the area of divergence moves to the north. So one of the key issues with this forecast is going to be where is the zero line at 850 and further up in the atmosphere? Are we going to get, who's going to get snow? Who's going to get rain? From a very cursory glance at the forecast just before we began, like where the rain snow line is going to be well to our north, so this should largely be a period of liquid precipitation over us. But I would imagine Minneapolis to the northern part of the state, going to Superior, probably going to get a significant snow event, maybe even a snowstorm. Let's go back.
It could be a storm, yeah.
You could say, yeah, I might use the word storm, and then finally at 60 hours. That vorticity maximum really maintains its integrity as it continues moving towards southern Lake James Bay. So that's out in the area at this point. So this is Sunday evening. We have this trough that's going by, the weaker trough. So looks like a period of rainfall. Let's look at a couple for this particular system. This is probably the cleanest example of sort of QG vertical motion, since we're talking about Q vectors briefly today in class. Let's look at the 24 hours tomorrow afternoon. Okay, we have this dipole of Q vector convergence and divergence. This is 700 millibars. This is average over a layer between 600 and 50 millibars. And a couple things to note as we step through this. Look at the pattern of the isotropes. Look at the orientation of the Q vectors. We have the temperature gradient is oriented this way, and the Q vectors are indicating the time rate of change of temperature gradient is going to tend to want to rotate gradient this way. So this is going to basically suggesting the formation of a thermal ridge forming over time just in this region. So if we go ahead, as this moves eastward, let's watch how that evolves. Let's go just 12 hours ahead. This time is a bit short. Okay. There's a really robust thermal ridge and a really nice dipole. Yeah. This is at 36 hours of the forecast. This is just before the rain's supposed to start for us. Let's look at the pattern of vertical motion, 700 millibar vertical motion at 36 hours. It's nice dipole here with the strongest vertical motions here. Again, this is at 700 millibars, integrated both the depth of this. But also, this linear band here on the first that ridge is also probably associated with significant research. Let's look at the precipitation at that time through 36 hours. So you can see again, first that ridge, in the dark, we'll see there precipitation. But here's with this upcoming weather event. There's a nice slug of precipitation just toward southwest, just about to begin in the Madison area. We can check with the TFS as well. Go ahead to 42 hours. The Q vectors first. Yeah, you get really nice Q vector convergence over the upper Midwest broadly. And when you invert this to get omega, it's going to get smeared out anyway. So broad ascent, you diagnose that over parts of Iowa, southern Minnesota, and southwestern Wisconsin. And if you go look at the vertical motion pattern at the same time at 42 hours, look further north one way, anticipating, but it's pretty much right on the money right there. And so at the surface at 42 hours, we're in the rain at this point. Yeah. And you can see thickness is 540 lines well to our north here. But you know, that's perhaps why they have these winter storm watches for significant potential for some significant snow in that band just to well to our northwest. But still certainly warm enough for liquid precipitation. And let's just jump ahead, surface map out to 60 hours. By then, this is the cyclone, pretty decent cyclone 988.
Yeah, that's
Run
pretty
of Bell. That's not nothing to be right home about. Although I don't know who writes home about cyclones.
I used to.
No comment. And cold advection in the wake of that when we get to Saturday afternoon, early evening, and a really nice front that is formed in precipitation. So finally, that southeastern ridge is going to get knocked down a bit. Just for comparison purposes, let's look at the GFS. We'll go to Pete's page, or whatever. Let's just look at 30 hours, so 36 hours. At the surface, again, the timing is about, very similar to what we saw in the MM5. Here's our 1,000 millibar cyclone located in northern Missouri, and you can see the heavy precipitation, or the beginning of the snow event over parts of south central Minnesota through Minneapolis, just on the edge, liquid precipitation. If we were to go ahead and click to 6 hours or 3 hours, let's go to 42 just to get to that's deepened quite nicely. We're seeing the liquid precipitation. But once this gets, beyond Green Bay or so, and the winds have firmly turned to the northwest over us, I guess it's just about to go northwest over us at this point. That's when the cold air is going to come, will return, and we could see this precipitation ending as maybe some frozen things. So let's go 1 to Sunday morning. And this is accumulated precipitation in that last 6 hours. So once this gets north of us, it looks like it just dries out. We may have some clouds around. With broad cyclonic circulation, cold air off, we're probably going to Sunday may start off with kind of cloudy with stratocumulus, and then eventually begin to clear out.
I think the subsidence behind the axis of the wave is really strong.
So it could just
that'll just clear the clouds right out. Is probably what's going to happen.
Yeah, it's actually pretty good. That's actually fun. Go to the time height section. Not the time height, the time height section we had back on the Go down. Yeah, I think John's instinct is right. So this is after the period very significant vertical motion flow. And then this is with the you can see how things really just dry out with this westerly flow. There's still a layer of about 90% relative humidity.
Yeah, maybe it'll be overcast a little bit
Right.
with.
I mean, the substance is strong, could have just capped that layer.
Right. Yeah. So I'm worried about now looking at this.
Right. One very last thing to run out of time. We see that trough shifting out of the central plain. Any chance of severe weather? Maybe go to the SPC page. See what's forecasted for the next few days. So it's marginal risk, I guess, for day
I saw
one.
the word strong tornado in the day 2 outlook, so
Uh-oh.
see if that comes to pass.
So yeah, this is day 2. You can see enhanced risk right here.
It's getting on
south
to
of it's that really sharp trough axis that's gonna be.
Yeah, and it's getting on to their season, down in Mississippi and Alabama.
Right.
It's really moist, those profiles are very tropical. Listening for the last few days, that'll probably limit buoyancy. I think it's gonna be kind of cloudy and there's a lot of insulation from the sector. But the shear profiles are best there.
So if we were to pick, what's a good time for a good shear profile?
18, 21, 0 on Saturday.
Okay, so let's go to that time period on the pivotal site. We can bring up the sounding. So 18 to 21 days, we'll get 33 hours. And where'd you?
Northern Mississippi, sure, Arkansas. So,
There's our graph.
yeah, there's some pretty nice turning in the low levels there.
What would you, what's, specific would you want to highlight there?
So, I mean, in terms of ingredients for supercells, you want to see pretty large deep layer shear. So, there's parameters there. You see surface to 1, surface to 3, surface to 6 of 64 knots is well over what's typically seen in supercell environments. For low level rotation in tornadoes, usually you're looking at low level shear, and we're seeing 0 to 1 of 30 knots. The helicity associated with that photograph is pretty large, which indicates pretty possibility of strong rotation in supercells, which is all reflected in that possible hazard type there of the tornado.
What is that?
It's
Possible hazards, sorry, okay, I see.
Yeah, I think the question is the instability. There's talking about a lot of convection. There's not much capping at all in any soundings I've seen. So
That's a negative then for this.
Yeah, right. And storm interactions would certainly be play, but I got it sounding pretty tropical. I don't think there's actually precip going at this time.
We can check that out. We close this out and go to this will be accumulated.
The mid-level lapse rate's like pathetic, which I assume is just based on the source region of that air, coming from maybe the Western Gulf versus what you want to see coming from the terrain of Mexico or something.
Yeah.
It's more like lapse rates. But yeah, this is okay. So there's already a lot of precip going on at 21Z. So is that sounding at 21 or 18?
Those at 21.
Okay, maybe we can go back a little and try to see the pre-feedback too. Yeah, maybe yeah, somewhere in northern Mississippi. See if there's just ahead of this piece here. It's not contaminated. And it's still pretty paltry lapse rate. But the shear profile is pretty solid. So. I think that's what's catching the attention of the possibility for tornadoes. So it's pretty good low level shear profile.
Just one other thing while since we're here, we'll wrap it up. We close this out, looking ahead to later in the week, but we saw that sort of simplification that Greg was referring to. Let's go to 144 hours. Or another, near the end of the middle end of this week, so maybe
Tuesday afternoon.
another trough that's about to emerge into the southern plains and another cyclone developing. So
That's right where all that was occurring.
right.
Oh, yeah, there's your small line, yeah.
This is, I'm guessing, there's gonna be an outbreak. This is one.
Thursday or Wednesday evening. Okay.
Yeah.
It looks like
It depends how the things come together.
What's that?
Yeah, it looks like the dynamics are a little more, that low is more intense compared to tomorrow's system.
Yeah. Down to 987 or 8, yeah. More than 8, yeah.
Oh, yeah.
So, looks like and then since it's been so wet, let's go to 384 hours and scroll down to the cumulative precip over the next
On May 1st, isn't it?
And again, just continue the hammer
Yeah.
after. You're saying, well, that looks
Brutal.
maybe all that's in the first period. Let's just look at the last 5 days of this. So actually, it is about largely only the first part of the period. But the western part of the United States, remember, we saw that was dry up there last weekend.
Hmm.
If this were to verify, this would be a nice change for that. And we actually stay relatively dry in the last part of this period. So, anyway, that's it for little chilly. Well, thank you, Melissa. Thanks, Greg and John and Ryan for comments and
Yeah, thank you guys for a great discussion today.
any questions at this time.
No.